So as we here this F, I denoted F as an acceleration, keep it in mind. So equal to 2AD, because previously somewhere we used to learn this acceleration is equal to F. So by practice of that I have written this. So this also ma, this F is equal to ma acceleration into d distance. Ma is equal to what? This force into d. So from this distance we can write this. So this is end of this part. Again we'll go to somewhere else from here. As we have learned the difference between two kinetic energy, one was v naught where it started, the initial velocity, another was vf, the final velocity. So their kinetic energy difference, it was like this, half, as we learned previously, half m vf square minus half. So from the previous what you have discussed, so what we got, half m vf square minus half m v naught square. What we get it? So we can different this delta k. So this delta k will be like this way. So this is a part. So this ends like this. So we'll get, it is the definition of the work. So we'll get the work part. The difference between the first, another thing is the difference between kinetic energy gives you the definition of work. So this is the part. Now after this we'll do the along with the gravitation, work along with the gravity, work along with the gravity. Let gravity we generally denote with the g part. Now this here, what we'll get, this, let the wg, this work, let we denote with the work with the wg. So as usual previously what we did is equal to this way as before. It will be a distance as cos phi. We previously did it, but here we'll add another g, the gravity part. So this is the most vital part while we'll do this part. So gravitational part is the very vital. So Fs, we did this, the work like this. So m mass mg d cos phi. This will give you another, the work along with the gravity. Okay, so now as usually we'll get this is the difference. What is work? Work is the difference between two kinetic energy. So here also it will be the difference between the kinetic energy in gravity. Okay, so this is the gravity. So this will give you this part. So keeping it is always in the mind. So as we recap it, the kinetic energy work are very correlated. if you do the work, there will be a kinetic energy. So simultaneously, if you get a definition of kinetic energy, we will get the definition of work automatically. So these are the very vital things. So always keep it in mind. Okay. Now, as we did previously, what we did, the difference of kinetic energy, the definition of work, whatever may be. Now, we will define the position of the particle, along with the gravity, and against the gravity. The scenario step by step we will do. So when it will be positive, when it will be the negative, the particle will draw the particle, as because it is a weight right now, I can write it, so it will smudge the ink. So that's why I'm discussing you the theories. So if this is the particle, I'm trying like this here. If this is the particle and if this is the distance, right? This is the distance. This is the distance. A particle. So a particle, and the particle is this first. So this particle along with or against this, so if it comes like this way, this is the particle, this is the particle. So the force will work like this, Fg. So this is work like F. Now, again, this is the particle is coming like this way. So again, what will be, this is again along with the Fg. The situation. Now, the scenario is continuously, when the distance is like this, it will become like this, the Fg. According to the gravity. This will work like. Now, the second thought, after this, the second thought will be this. If from here, if a particle walks like this, so it will be what? If Fg, everything, so this work will be F. It will go like this way. So these are the actually conceptualization. So this will, when according to this will cover like this, up to this distance, this work, the final, it will be like this. So this is the conceptualization. The body will be denoted by Fg, but when the body is parallel to this distance above of this will be Wf. So this is the conceptualization. You have to learn like this. Now, this is now what we previously did. mgd cos phi. This was the definition of what we previously did. From here, all the scenario, this phi, if this phi, along with this gravitation, this will be 180 degree, this will be 180 degree. So we'll calculate like this way. So in the case of phi, if this is the phi, so we'll place this phi here. So what will be the formula? mgd cos 180 degree. Got it? So mgd 180 degree, this is the scenario. So what will be? This is 180 degree will be what? mgd minus 1. So it will be minus mgd. So this, the gravitation, when you use this gravitational formula, this work will be minus mgd. So these are the scenario. You have to feel like this way, and the concept should be clear like this way. Now, what we did so far, we did work done, the straight line, energy, and the work done along with the gravity. Now, along with the gravitational force, and with the gravitational force. We did it. So later on, what we'll understand? Actually, if you recap all the things, these are the very minutes. As I told you before previously, W is equal to Fd. We denoted distance as a d. F is equal to force. W is equal to force into distance. So this will be like this in a straight line. When it covered like with an angle phi, so it will be W is equal to Fd cos phi. So continuously like this, we'll thus conceptualize the scenario. So again, when W is equal to mgd cos phi, and this mgd cos 0 degree, cos 0 is equal to 1. So mgd into 1, it will be mgd. So two scenario against the gravity, along the gravity, it is a minus and plus. So W is equal to two cases, W is equal to plus minus mgd. These are the two cases. So always keep it in mind while doing the kinetic energy and the work, all are along with the straight line, along with the gravity. Against the gravity, along with the gravity, and along with the straight line. These are the two conceptualization thoughts. If you do the work, if you do, you will get automatically the kinetic energy. Okay.